Hi everyone! So you might be wondering why I have a part 0 to the video for the first time. Well, the truth is, in part 1 I noticed I made a mistake in that for some reason technology died on me and only half of my video ended up playing, and it ended up being the last half of the video. So obviously that's a mistake and I'm just going to fix it by re-recording the first half. So anyway, this is video 11 and today we're just going to go over a bunch of practice problems regarding recursion and higher order functions. But before we do that, I want to talk briefly about printing with recursive functions, mainly using the print function within a recursive function, because this does some interesting things that we do need to talk about. So instead of going into the details of this though, I think the best way to illustrate is just to look at an example. So I'm going to define a function called cascade. And what this function is going to do is it's going to print out a very beautiful pattern. So let's just write this function. So now I'm going to call it recursively on n florative 10, and we're going to pass in an integer to cascade 1. Okay? So let's see how this works. And now I'm going to call cascade 1 on 1, 2, 3, 4. And we get this pattern. So let's look at how this works. And the best way to do that is, I think, by looking at an environment diagram. Okay? So, first we define the cascade function. Then we call it, create a new frame. Now, is this less than 10? No, it's not. So the first thing we do is we print this. And then we call cascade again, but our new argument, or the new value of n, is 1, 2, 3. And so now, when we print n in the current frame is 1, 2, 3. So then we print 1, 2, 3, and then we continue to do this until we reach the end where we get to the base case. Then we print 1. Okay? And now the key thing here is once we print 1, what does this return? There is no return statement, so it returns none. And where does this get returned to? That gets returned to this call. And then this call has no return statement as well. So we return none repeatedly all the way up, and then we end our function. This might not seem important right now in this example because it didn't result in any printing, but this is going to be very important in the next example. Alright, so this is basically how that worked, and it created this output. Now, the first question I have today is how can we modify cascade 1 so that it displays the following one called. So basically, before we had this pattern, now I want to get this pattern. So how can we do that? So I'll give you some time to think about it, but now I'm going to spoil the answer. It can actually be done with a very, very small modification to this function. Mainly, I'm going to move this print statement from here, and I'm going to move it to down here. So this is interesting. It's going to be after the recursive call. So let's look at, make sure that first that this works the way it's supposed to. And we get that pattern. Great. Okay, now let's look at how this works with the environment diagram, because I think that's the most illustrative way to show these type of examples. So we first again define the cascades function, as always, call it, create a new frame, and now once we're here, we now called it again. So previously we printed out the value, now we're going to call it. So nothing's actually going to happen. There's no output yet because this function call hasn't returned anything. So this is going to keep on happening until we get to the base case. And then when we get to the base case, we get our first print. Well, hey, what's n? N is 1 in the current frame. So we print out 1. And then also, this has no return statement. So now we return none. And where do we return none to? Right here. So once it's done that, it can execute the next statement, which is another print, n. But what is n here? N is 12. So now we print out 12, and then this pattern continues, so now we return none back up to here, and then we print 123 because that's the current n. And this continues all the way until we go up there. So that's how this cascade function works. And the key point here, the one that I really want to hammer home, is that the fact that the return statement returns none and goes to the previous call is the key to getting this pattern. Because if that didn't happen, we wouldn't be able to get this pattern. So understand that even sometimes recursive calls, when they return to the previous frame, and in that frame we might have a different binding of n. Okay, so that's very, very important when we're doing recursive programming. So keep that in mind. And so from here, I move on into this example, and that's the next question in the video part 1. So this is, for some reason before this got cut off, so don't be confused. Alright, thanks.